Hi all, I am pleased to welcome Mr. Davey Shafik to speak about the HTTP, HTTP2 and asynchronous APIs. Yeah.
I like to get a panorama to prove to my wife that people actually come and see me speak. So, uh, uh, good afternoon. It is now. Yep. So I'm Davey Shafik. I'm a developer. I have been for about 15 years. I'm an author. I have a couple tech books out. I'm an open source contributor. But most importantly, I am at dshafik on Twitter. So if you have feedback or anything else, then that's the best place to reach me. I am a developer evangelist at Akamai. Who's heard of Akamai? Okay, so it's a really cool company. We carry about 1/3 of the internet's traffic, so we solve some really cool problems. Check out developer.akamai.com. We're not just a CDN. I also always like to mention Prompt, which is something I'm involved in, trying to get people talking about mental health issues in technology. So check that out at mhprompt.org. All right, HTTP2, also known as H2. It's a thing. We know that because it has a logo. But what is HTTP2? So HTTP2 is actually two different RFCs. It is RFC 7540 and 7541, which is HPAC, which is the header compression stuff we'll look at later. It is created by the IETF working group, which is chaired by Mark Nottingham, who's a coworker of mine. So HTTP has been around since 1991, first spec was 1991. HTTP 1.0, which is kind of as we know it, came around in 96, and then 1.1 in 99. And then we had nothing for 10 years. And then Google said, we're kind of fed up with this, and we're going to create something called Speedy. And Speedy's pretty cool. It has some problems, but it's pretty cool. So they took that, and in 2015, they released the spec for HTTP2, which is based on Speedy. Now, as far as browser support, 60% of the browsers currently out in the wild with users support HTTP2. So this is something that's out there that you can use today. That includes Chrome, Chrome Mobile, Firefox, IE 11 if you're on Windows 10, and Edge. It also includes Safari if you're on El Capitan or iOS 9, but not Safari on Yosemite, and Opera, but nobody uses it, so who cares? The big thing about H2 is that it is binary instead of plain text. And this gives us two things. It's a much more compact protocol, and it's also much, much easier to parse because it's much more succinct and regular. It's fully multiplexed, which means that you can have multiple things going on within the same connection. So you can use one connection for parallel requests. And it has this header compression called HPAC, which is actually really, really cool. My favorite feature, though, is server push. And what server push does is it allows the server to proactively push assets down to a client that it thinks that they might need. So you request an HTML page, it goes, well, you're going to need the style sheets, you're going to need the JavaScript, so we're going to shove those down to you without you having to make a request. The way that this works is it actually pushes those assets down into the browser cache, and then when the browser makes that request, it pulls it out of cache instead of making the request to the server. So what does using HTTP2 mean for your application? For the most part, it's going to be completely transparent. It's going to be handled at like the Nginx or Apache layer or whatever web layer you're using. Your application isn't going to know and isn't going to care. So what's the point, right? Like if you don't have to do anything, it just works. What's the point? The point is that HTTP1 sucks. And the reason that it sucks is we have to do a lot of things to make HTTP1 fast. Things like minifying and concatenating JavaScript and CSS, inlining small JavaScripts, your critical path in your CSS and your applications, using things like image sprites or data URIs or domain sharding. If you don't know, browsers have a limit of 6 connections to a single domain concurrently. So what we do is you'll have s1.domain, s2, whatever, and that's just so we can skirt around that limitation on connections that can handle it. All of these things are hacks. They're very clever hacks, but at the end of the day, they are hacks on a protocol that we're doing things with that really weren't thought about when the protocol was made. So as I mentioned, you can now start to make parallel requests within the same connection. So let's take a look at an example, uploading multiple image files. So this is We've got a web form. It's got multiple file inputs. Go ahead and upload multiple image files. So we start off with client and the server. We shove all the data up. There we go. Open the connection, shove all the data up. Server receives that, and then it might do something like open up a connection to, say, S3 or Akamai Net Storage, and it will start pushing those images over to the persistent storage, right? This is not great. So what we start to do is do things concurrently. We start to use things like AJAX. So now what we do is we open up 3 connections, and we send 3 requests, and then on the back end, those come in separately, and we then open up 3 connections to the back end, and we send 3 requests. So we've got a performance benefit, but we've got some extra overhead here. We're also going to look at APIs. So what I'm going to show you is a terrible API, but it's for this example, so don't put it in production or anything, but we're going to look at fetching a blog post and the comments for it. So have a client. This time it's going to be code and a server. So we open up a connection. We go ahead and make a request to the blog post. We want to get the first blog post. And we get a JSON response. Maybe it looks something like this. Now, we have the type, ID, titles. We also have 2 links here to the author and where their data is and the comments. So if we go ahead and decide we want to get the comments, start another request, make another get, this time to the comments. Now, in an ideal world where we're doing RESTful APIs, where everything's a resource and everything's great, what we would get back is another JSON response that is just a list of resources. So let's go ahead and get the individual comments. So now we need to make 4 more requests, right? So starting to get a little tired, starting to get slow. Here's a comment, right? And in here we've got author information, and maybe they have bio pictures, all these kind of things. You're making at least 6 requests, maybe as much as 14, and possibly connections. More likely they are connections as well. That really sucks. So what we can do with H2 is we can multiplex this. At the very least, this is the very first level of optimization that we can make, which is do everything on one connection, remove all the overhead of that. So with multiplexing, we just make all the requests that we want, and we get all the responses within the same TCP connection. So that's good. All right, let's take a look at some code. We're going to start with this very simple line. Num requests equals 378. The reason I chose this is it's based on this little demo here, which is if you go to http2.akamai.com, you can check this out for yourself. Essentially what it does is it loads 378 tiny little tiles to build the Akamai globe. On the left, we have HTTP1, and it takes, I think, 13-something seconds. You see, quite slow. And then HTTP2 with multiplexing. Obviously, much, much faster. So let's take a look at what this would look like in code. So we're going to use PyCurl. I happen to really like curl. I know requests is very popular, but curl's pretty consistent, and it has good HTTP2 support. So we're going to use PyCurl and do a simple for loop, create our curl client, tell it the URL and what data we're going to send, and sorry, actually, that's actually telling where the output's going to go. And then we're going to perform those requests. So just a very simple loop doing 378 requests. That takes about 20 seconds. It's not great. If we switch to HTTP2 now, very similar, except that now we have this extra set opt that tells it to use HTTP2. It's the only change we're going to make. And now it takes 34 seconds. And you're all probably going, what the heck, right? This is terrible. This is slower. We'll get to why that is, but it's really important to understand that in this context, HTTP2 actually has extra overhead, and it's not good. Let's take a look at concurrent requests now, and this time we're going to use curl multi. And what we do there is we set pipelining to 1, which uses HTTP1 pipelining. This is something that's been around for a while, but honestly, it's broken and janky. The way that this works is you create those requests, and instead of executing them immediately, you add them to the multi-handler. And then you can tell it to execute all of them in parallel. And I hate this code. It's the same in every single language that I've looked at. It's this double while loop or do while loop sometimes. Essentially what we do is we have a while loop that checks until there is a response, and then from that point on it hands off to the second while loop and actually handles those responses. And this takes 6 seconds. And this is just HTTP1 with pipelining. So this is great, from 20 seconds to 6 seconds. That's a good improvement. If we then switch to HTTP2, only change here, other than setting it to an HTTP2 request, is setting pipelining to 2, which is to use multiplexing. And when we do that, this is exactly the same. We don't change this code at all. We get down to 4 seconds now. So now we're starting to see some benefits from HTTP2. Let's talk about why it was slower, because this is really important to understand. To make HTTP2 compatible with HTTP1, there's a negotiation that happens. And that can happen in one of 2 ways. It can be an HTTP1 request that says, I want to be HTTP2, do you support it? And they go yes, and it transfers over to HTTP2. Or it can happen in the TLS negotiation, which is typically what happens. So there's 2 protocols. There is H2, which is TLS, HTTP2 over TLS, and there's H2C, which is plain text. Now, because none of us can read encrypted code, I'm going to show you what the H2C looks like, but in all actuality, you would never actually have that in the wild. So when it's done for H2, though, it's done over ALPN, which is the Application Layer Protocol Negotiation. This is an RFC that was published in 2014. This has been out there for a while, and it's just part of the TLS handshake where they decide what protocol they're going to use. So this is H2C. We send a GET request. We also send a upgrade header. It says we want to be an H2C. And then we have to send this HTTP2 settings header, which is basically a base64 encoded part of the HTTP2 stream that would normally be in binary. And then the server responds with an HTTP 101 switching protocols if it supports it. And from that point on, that connection is now an H2 connection. Something that's really important to understand here is the type of request that you make doesn't matter. You can use options, head, post, put, delete, whatever. But if you send a body, that upgrade can't happen until the entire body has transferred. So if you want to send 50 images and you send the first one with this upgrade, until that first image has been sent, you can't actually upgrade and start utilizing H2. So do a very simple get or an option, something like that instead. It's great. This slide. So as I said, you're never actually going to see that in the wild. All browsers require TLS for HTTP2. One thing I do want to check on, I noticed the other day they had, they moved the geolocation JavaScript API so that if it's not on localhost, it has to use TLS. I'm hoping they actually have an exception for TLS on localhost for H2 as well, but I need to check on that. That would make sense. But yeah, so all browsers currently in the wild require TLS. Now, if you're using curl or something like that, then obviously you get to make that choice, but that's just how it is. It is also possible to remove the overhead entirely. You can do direct connections with H2 using what's known as prior knowledge, and in that case, what happens is instead of sending that upgrade, they send a identifier, and then another identifier comes back if it's supported. Downside is it's not backwards compatible, right? So nice thing about the other is that it is. So server push. This is, as I said, my favorite thing about HTTP2. This, for me, is where things can become really, really exciting. So we looked at multiplexing and what that can do for our API, but it's not great. We can do better than this. We're still making sub-requests, unless you do what most people do, which is they kind of take all those sub-resources and they munge them into one larger resource, right? We have to make this trade-off, just like we do with concatenating all our JavaScript and stuff like that. We have to make the same trade-off with our API responses. So if I actually go ahead, and this is like what you end up with, this huge document. Zoom that in a little bit. So here we have the author stuff embedded in right there. Comments now become an array with that stuff in there. That's another sub-document, and it's got its author content in there as well. If you have duplicates, so like I've replied to a comment on my own blog post, now we've duplicated the author information, someone else that's commented responds, like you've got so much, this is ridiculous, this is terrible. So what we can do is we can utilize server push and change this. This is fantastic. So client server, open up TCP connection and make that initial request. Get a response back. And then the server says, but we know that most people calling this are then going to go and request comments. So we're just going to send that to you. And then we're going to also send you the comments, because if you want the comments, you actually want the content of them, right? So let's send all of those. And then you're probably going to want the author information and maybe their images, whatever. So we can just start sending these to the client without them having to make those requests. Now, on the client side, you have control of this. You don't have to accept that information. What ends up happening is they say, we want to send this push to you. The client says yes or no. And if they say yes, then they start getting that information. So they are in control of that, which is really important on like mobile clients. So if you're not on Wi-Fi, they may stop, they may reject pushes, for example. What this means is things like CSS and JavaScript minification are completely useless now. We don't need them anymore. This is great. You can just get by with server push and gzip. That's it. Right? So this allows us to remove some of that overhead of HTTP1. Some of those hacks can go away. Let's look at HTTP2 as a protocol. So the way H2 works is it has this concept of streams. And each request and response is a stream. They're comprised of frames, which are the subparts of that stream. And they each have an ID, so we can see what belongs to what stream. They have a weight, which is something between 1 and 256. And they may also have a dependency, which is really cool. We'll look at that in a second. So here we have weighted streams. Now, the way that the weighting works is it allows the server to inform the client of how much of the proportion of resources they should be giving to any given resource. So in this case, we have stream A, which has a weight of 1, stream B, which has a weight of 2, so it's twice the weight of stream 1, so it gets twice as many resources. And then stream C, which has a weight of 3, which means it gets 3 times stream A or 1.5 times of stream B, whatever that equates to in whatever resources they have available. With dependencies, we can now say things like, I'm sending you a style sheet. I also want to push you the fonts, but unless you've got the style sheet, they're useless. So wait till you got the style sheet and then start grabbing the fonts, right? So that allows us to do things like that. It's pretty cool. So all of this is comprised of frames. These are the smallest parts of the HTTP2 protocol. And they are things like headers, data, which is your message body, settings, which is that HTTP2 header setting that we sent earlier in the upgrade request. That's one of the frames. There's also frames for like sending a push or killing the connection. Each frame has a common header, super easy to parse. The first 9 bytes tell you what kind of frame it is, and they're length prefix, so then you know how long the frame is to parse it. So they're super easy and efficient to parse. What this means is you can start to use less resources on your server side to handle those requests. And then what's really cool is frames can be interleaved, and that's how we have multiplexing. We send frame A from stream 1, frame A from stream 2, and we can just interleave all of these different streams. So this is what a request might look like. So we have the HTTP1X version on the left. So all of the headers go in a header frame, and then the body of that goes in a data frame. Very simple. Now, headers are compressed using HPAC. Now, this RFC is really important. I mentioned there were some pitfalls in Speedy. One of those is that when you encrypt compressed data, it's actually really, or much, much easier to figure out what that data is. So HPAC gets around that. I honestly don't know how, because I'm not a security person. But that's the whole point behind HPAC. And what HPAC does is it uses a known table of values as an index. So rather than send a full header, you just say, I want index X from this table. Those may represent both the header itself and a value, or they may just represent the header and then you send the value after it. So content type, for example, would be an example of one that's just a header, and then you would send application JSON along with whatever ID represents that. They are either statically encoded or they use a static Huffman code. What's really cool about that index is that you as a developer can actually append to it. So for example, cookies, you can now put those in that table, and rather than sending the cookie back and forth, you just send the identifier back and forth. So you get great compression with that, or not really compression, but substitution. So there's 64 default entries in that table, but this is the first 15. So you can see one is authority get, so we have header and a value. There's also things like path index.html. So we're not just looking at traditional headers here. We're also using this to compress some other parts of that request. So status codes now become part of this. You can see down here the scheme, things like that. And as I mentioned, the greatest thing about this is that you can add to it. So in summary of HTTP2, no more hacks. Domain sharding goes away. You can do it all on one connection. Compression, minification goes away. All those things I mentioned, gone. You can get some huge performance wins so long as you are aware that if you're in that make a request, get a response type scenario, you're just doing one request at a time, you're not going to get it unless you're doing prior knowledge stuff. Curl does, I think Curl just added support for prior knowledge, but up until now they haven't supported it. And 60% of the market already supports this. Apache supports server push as well as the rest of HTTP2. Nginx, and I hate this, does not yet support HTTP2. The way server push is generally implemented is you send a link header with the path to whatever you want to push, and then you have rel equals preload. And then the server will see that from your application and handle it. So what's really nice about that is you don't have to modify your application because you're already responding to web requests. You can already send headers, right? It's all done at the HTTPD level. So HTTP2 is awesome. So at this point, I would love to answer any questions. Anybody? Very comprehensive, or yes? Do you have a mic or? Oh, everyone over there. Hang on, let me walk there. I have hearing aids, so I can't hear anything.
Hey, thanks. That was really good. I'm curious, I guess, about so there are some things that are trying, I think, to attack some of the problems that you were mentioning about making multiple requests on the API side. So stuff like I think like Ohm and Relay and Falcon and those things, which basically are creating kind of like query languages on top of HTTP in a thing that isn't exactly REST, but basically is trying to solve problems like this, where you basically say, here are the resources that I want, here's the joins that I want the server to make on them, and then kind of you make one request and get one response back with the data in the form that you need it.
Yes.
I'm curious if you have kind of thoughts about how those sort of things fit alongside HTTP2, or if you kind of, I know that was just one example, but basically if you have any thoughts.
I was actually thinking about this earlier today. So in my opinion, that's a great way to kind of have a migration path. So this idea of munging API requests together is certainly a valid one, and it absolutely works now with HTTP1s. This is not something we should be throwing out. But what I would love to see in that case is if they are an HTTP2 client, that rather than munging them into single requests, we would then actually send discrete responses. And the nice thing about that is that we can cache them separately and we can do different things with them. So I would like to see kind of that hybrid setup, but it's not really my call to make. That would just be where I think people should be looking at. There was a question over here. In the back.
I was just curious about multi-part and HTTP2 handling of that and streaming scenarios. Could you say something about that?
So you say multi-part, you mean like multi-part MIME? So yeah. So none of that changes. All of the HTTP1 stuff works exactly the same. The only thing that changes is the multiplexing within the single connection, which is not really part of that. As far as streaming, one of the things that most people assume is that push is something that the server can just kind of initiate at any time, kind of like a push notification. It has to be within a connection that was initiated by the client in the first place, and they have to have made some sort of request to do that. So there is a potential, I suppose, that you could say do an options request to / notifications, and then you would just leave that connection open, and then whenever they have them, you would just send do pushes. But yeah, it's not. You still want to be looking at things like WebSockets for streaming.
Hi, good, nice talk.
Thank you.
To begin with, I was thinking about DDoS attacks.
About what? Sorry.
DDoS.
attack?
Yeah.
Okay.
So if you make a small request but get a whole lot of more stuff back.
Yeah. So
yeah. So just your thoughts on that.
you're talking DDoSing the client in that case.
I guess it would be the server as well, since
yes. Okay. So
since you get it to just give you.
So in an ideal world, so the way that the pushes work is that they send a single frame. It's called a push promise that says, hey, I have this stuff. Here's some headers and some information about it. That's all we're going to send you until you acknowledge that and say it's okay. And they send another frame back to, I think it's a continue frame, to say, yeah, sure, go ahead and send that. On the server side, hopefully, you're not doing anything other than sending that push promise. I don't think that's the way it's going to work because, for example, maybe you don't know content length until you completely generated the content, things like that. We're going to have to do some work as developers to kind of look at best practices around these kind of things. I think that this is one of the ways that HTTP2 is going to change the way we architect our applications.
So there are sharp edges to file down.
There definitely, I feel like the potential for HTTP2 is massive. And because it is backwards compatible, it means it's fairly trivial to kind of enable it and forget about it. But with this idea of push and multiplexing, we have a lot of new opportunities available to us if we spend perhaps a lot of time actually deciding how our applications work. And that might be that we don't push until we've cached it, for example. So we've got things like the content length. But yeah, there's definitely some things that we're going to have to start thinking about. And I think it could have huge impacts on the way that we architect the web.
Yeah, sounds like there are some interesting patterns that are gonna show up.
I think so. I hope so.
Cool,
So.
thanks.
There's
Hi, nice talk. I have a question about keeping alive the session so long as it could be done then. Doesn't it create bottlenecks on the server side? Because if you have massive amount of users, you run out of sockets basically.
Yeah, I mean, it's the same in doing like keep alives in HTTP1. It definitely is potentially a problem. Hopefully, the way that you're mostly going to see this is things like I'm making a request and getting all the stuff for it. That's all requests that you would normally make, and you're not going to keep it open longer than that. But again, this is going to be part of that whole how are we going to architect these things.
But on the other hand, is there any way for the server to just say aborting and sending a notification that I'm reusing this socket for something else, for someone else, not the same session for someone else, of course, but.
There is a way to tell the client that you are canceling the connection. That is something that is there. You don't just cancel it. And same for the client side of that, but not specifically for that purpose. It's just I'm done with this.
Okay, thanks.
Anything else?
Yeah, great talk. I have questions about your slides. They were beautiful, and I would like just to know what you used to create them.
I use Keynote.
Okay.
I have spent a lot of time on getting those animations and stuff in there. It's Magic Move mostly, but yeah, it's all Keynote. I use the Monokai theme, which is available in Vim and everything else for the colors. But yeah, so thank you.
Thank you.
Any other questions? Doesn't have to be about H2. Apparently, we're pretty much anything. All right. Well, I guess thank you very much. Yeah, if you want to see how I do those, I'm happy to show.